Okay, we're going to get started with our lecture notes, our classwork today. We're going to be working on the Pythagorean Theorem again. We're going to continue solving some word problems. And basically what you're going to do in the classroom looks something like this. That Google slideshow is right here. You can open that up. If you can print it out, or if you can save a copy and you have a tablet that you can write on, you can do it that way. Or you can just follow along with the video, pause it, and do this work on lined paper. I'm just going to do the work on the slideshow on paper. Kind of just right here like this. So you can pause this video and kind of draw this stuff out on lined paper, right? So you've got some lined paper and you're just going to put your name at the top. And you're going to write 12.1b and classwork. For the Pythagorean Theorem. Pythagorean Theorem. And again, we know that the Pythagorean Theorem states that a squared plus b squared equals c squared in right triangles. And that means that the two legs are sides A and B, and the side opposite of the right angle is called the hypotenuse, or C. It's the long side of the triangle. All right, so we're working out problem 1 right here, just like this. Okay, this is what you're doing if you haven't printed it, or if you don't have a tablet where you're doing the work there. Okay, so number 1 says the diagonal of a rectangular big screen TV measures 152 centimeters. That's pretty important. So I have a rectangle and it's 152 centimeters from corner to corner. That's my diagonal, right? So this is number 1 here. And the length measures 132 centimeters. So we're going to say the length is 132 centimeters. And then we're going to say the corner to corner diagonal is 152 centimeters. And then I've got a right angle here. This side opposite the right angle is the hypotenuse, that's C, and my legs are A and B. Okay, so I have a squared plus 132 squared equals 152 squared. So then I just grab my little tool right here, and things a little bit. Let's see here. So I'm going to do 132 squared. Clear that all out of there. 132 to the second power equals 17,424. 17424. So a squared plus that out equals, let's see here, 152 to the second power, 23,104. And now I just have this two-step equation where I subtract this value from both sides so that I can isolate my variable, so I can get that a all by itself. And if I do 23,104 and I subtract 17,424, I get 5,680. And that's equal to a squared. So if I take the square root of both sides, right, these canceled out here. If I take the square root of a squared, I find what a is equal to. And if I take the square root 5680, 75.365, 75.4, 75.4 centimeters. Okay, so that's the height of that big screen TV in number 1. Okay, then we look at number 2. Look at number 2. You can pause this video anytime, right? You can also open the digital copy in the classroom. Okay, I'm going to do number 2. Actually, that's 1B. Dylan has a square piece of metal. It measures 10 inches on each side. He cuts the metal along the diagonal, forming 2 right triangles. Okay, so there's a square piece of metal that's cut diagonally. What is the length of the hypotenuse of each triangle to the nearest tenth of an inch? All right, so he made 2 right triangles, and they're 10 by 10. And we're trying to find the length of the hypotenuse. Okay, right? Because square piece of metal, 10 inches on each side. Cut along the diagonal, forming 2 right triangles. So there's my right triangle. What is the hypotenuse? So let's just do 10 squared plus 10 squared equals c squared. And we know 10 squared is 100, plus 100 is 200. So then let's just find the square root of 200 to find the length of the hypotenuse. So, second root 200, 14.14 to the nearest tenth of an inch, so 14.1. C is approximately 14.1. And we're talking about, let's see, those are inches, 14.1 inches, or IN. Is equal to the hypotenuse C. Okay, that's 1A and 1B. We're going to move on. Solve some more problems here. These are real world problems, real world situations. This applies to us in life. I'm just going to fold this over. I'm going to do number 2. I'm going to keep going on this line paper just because it's working. Okay, a painter has a 24-foot ladder that he is using to paint a house. All right, so a 24-foot ladder. For safety reasons, the ladder must be placed at least 8 feet from the base of the side of the house. 8 feet from the base of the side of the house. To the nearest tenth of a foot, how high can the ladder safely reach? All right, so here's my house. Here's my house, and I need to be 8 feet away. All right, 8 feet from the base of the side of the house, and the ladder is 24 feet. So there, my hypotenuse is 24 feet. To the nearest tenth, how high can the ladder safely reach? Okay, so I know a squared plus b squared equals c squared, and this is a right triangle. So this is the hypotenuse, and this is a or b, and this is a or b. And so we'll do 8 squared plus b squared, we still don't know what that is, equals 24 squared. Let me just work this out. Let's see, 8 to the second power. That equals 64. And 24 to the second power, that equals 576. So 64 plus b squared equals 576. And I subtract 64 on both sides. So minus 64 equals 512. And then I'm going to take the square root of that, because square root of b squared tell me what b is. So I do that on both sides, and I do second root 512, 22.62, and it says to the nearest tenth. That 2 says stay at 0.6. So b is approximately 22.6 feet. And that's how high that it can safely reach if it needs to be 8 feet from the base of the house. Okay, that's number 2. We're going to keep rolling here with number 3. We're just going to keep rolling. We're going to skip number 3, actually, and we're going to go right to number 4. Skip number 3, that's for later. Right on to number 4. And I don't think number 3 is in your digital copy. Okay, we've got an American football field measures 100 feet long between the end zones and 53.5 yards wide. Is the length of the diagonal across the field more or less than 120 yards? All right, so I'm gonna draw this football field. It's a rectangle. It's longer than it is wide. Okay, I've got my 2 end zones, right? End zone, end zone. In between the 2 end zones, there are 100 yards. 100 yards. And then they're 53 1/3 yards wide. And we're trying to find the length of the diagonal across the field. Is that going to be greater than or less than 120? Is C greater than or less than 120? Because this is A and this is B. So we're going to do 53 1/3 squared plus 100 squared equals C squared. Let's do this. Clear that out. Let's see here. 53. Let's see here. ABC 1. ABC 3. Up 2 equals. Okay. And then let's do plus 100 up 2. So that equals 12,844. 12,844.4 repeating. And we know that's 4/9. So we could type that into our calculators very precisely. So we're trying to find the square root of that value. So we're going to do square root 12,844 ABC 4. That's 113 1/3. 113 1/3 is equal to C. And the question says, is the diagonal across the field more or less than 120 yards? Well, let's raise that to the power of 2. So if we did 120 to the second power, it's 14,400, which is greater than 12,844 4/9. So the answer is the diagonal is less. The diagonal than 120. 20 yards. It is actually 113 1/3 yards. And that's the answer to number 4. Okay, we're going to keep going. We're going to go on to number 5. Pause the video anytime you need to. We're going to keep rolling here. We're trying to justify some reasoning with this problem. Okay, a tree struck by lightning broke at a point 12 feet above the ground as shown. What was the height of the tree to the nearest tenth of a foot? Explain your reasoning. All right, so this one is asking me to find what was the height of the tree. What was the height of the tree? So I know that it's still got a 12-foot piece right here. And I know that from there to there is 39 feet. Okay, so I can find how long this broken piece is. I can find the hypotenuse C because I know what A and B are. Okay, so I'm trying to find the height of the tree to the nearest tenth of a foot and explain my reasoning. Well, I know that 12 squared plus 39 squared is going to equal C squared. Let me just grab my little pocket computer. And I'm going to do 12 to the second power plus 39 to the second power equals 1,665. 1,665 equals C squared. And then I take the square root of both sides. So second x squared 1,665. And I get 40.804. 40.804. And it keeps on going. Right? It keeps on going out there. Is equal to C. I'm not going to take that out. What I'm going to do is I'm going to add that to the height of the piece that's still standing. So I'm going to add 12 equals 52.804. Okay, so if I add the 12 that's still remaining, I'm left with 52.804 equals A plus C. That should be the height of the tree to the nearest tenth of a foot. That's the piece that's still standing plus the length of the piece that fell over. 52, and it says round to the nearest tenth, so 52.8, that 0 tells me to stay there, feet was the height of the tree before it broke. That is the sum of the hypotenuse or the broken piece and leg A still standing. And that's your explain. Okay. Let's see here. Move that over. You can pause that anywhere you need to. And we're going to move on to number 6. I don't want to keep at this all day, but we need to develop our problem-solving skills together. So let's keep going. Main Street and Washington Avenue meet at a right angle. All right. So I'm going to do this. I'm going to draw Main Street and Washington Street, right? There's a right angle right there. A large park begins at this corner. Joe's school lies at the opposite corner of the park. Usually Joe walks 1.2 miles along Main Street and then 0.9 miles up Washington Avenue to get to school. Today, he walked in a straight path across the park and returned home along the same path. What is the difference in distance between the two round trips? Explain. All right, so normally, let's call this Main Street, and let's call this Washington Avenue. Okay. The large park begins at this corner. Well, that doesn't really matter. That's kind of garbage. Joe's school lies at the opposite corner of the park. Joe walks 1.2 miles along Main Street. So this is 1.2 miles. And then 0.9 miles up Washington Avenue. 0.9 miles on Washington Avenue. All right. To get to school. So this is home and this is school. Today you walked in a straight path across the park and returned home along the same path. So we want to find this right here. What is C? What is the hypotenuse? Well, let's figure this out. Normally he walks this way, and then that way, and that way. So he walks this way, and then back. So he walks 1.2 times 2 plus 0.9 times 2. So normally he walks 2.4 plus 1.8. So normally he walks 4.2 miles round trip. That's when he walks to the corner and then over to the school and to the corner and back. Well, now if we find the hypotenuse, so if we find the length straight across the park, we're going to do that using our Pythagorean theorem, right? So I'm just going to plug in some values here, right? I'm going to put 1.2 plus 0.9, 1.2 squared plus 0.9 squared equals C squared. Okay, let's do this. 1.2 to the second power equals 1.44 plus 0.9 up 2 equals 2.25. 2.25 equals C squared. And then if we take the square root, that should be 1.5. Let's see. Second root, 2.25 equals. So 1.5 equals C. So C is equal to 1.5 miles. Well, when he walks straight across the park and back, he does 1.5 times which equals 3 miles. Now the problem is asking, what is the difference in distance between the two round trips? So if he walks around, he goes 4.2. If he walks straight across, he goes 3. So 4.2 minus 3 equals 1.2 miles difference round trip. So the difference is 1.2 miles. Because the round trip around the park is 4.2 miles. While the round trip across the park is only 3 miles. Okay, and that's the solution to number 6 and the explanation. Okay, make sure you have all that, make sure you understand it. Ask questions if you don't. Okay, we're going to go on, we're going to look at number 7. I'm going to try and get this wire away. Let's see here. We're going to analyze relationships. Okay, an isosceles right triangle is a right triangle with congruent legs. So those legs are equal in length. If the length of each leg is represented by x, what algebraic expression can be used to represent the length of the hypotenuse? Alright, so an isosceles right triangle has congruent legs. The length of each leg is represented by x. So I'm drawing an isosceles right triangle. And the length of each leg is represented by x. What algebraic expression can be used to represent the length of the hypotenuse? Well, it could be, this is A, and this is B. So, replace A with x and say x squared plus, replace B with x and say x squared equals c squared. So how many x squareds do we have there? Well, we can combine this 1x and this 1x squared, and we get 2x squared is equal to c squared. And that would be the algebraic expression we can use to represent the length of the hypotenuse. And that's because the legs are A and B, which are equal. So we can call them both x. And if x squared plus x squared equals c squared, then 2x squared also equals c squared. And that's how we analyze that relationship in number 7 about isosceles right triangles. And number 8, this is going to be the last problem we're going to work on in this one. This one's really pretty challenging, okay? This one kind of is multi-step, and it involves understanding lots of different concepts. So we have a square hamburger, which is centered on a circular bun. Both the bun and the burger have an area of 16 square inches. So my square is 16 square inches. So if I call my sides x, well, I know that x squared is equal to 16 because area equals side squared, right? And we know that the area equals 16. Okay, and so the sides are both x. They're the same on a square. So if I take the square root, well, then I have x equals 4. So I know that my square has side lengths of 4. Okay, and then to find the area of a circle, see what I can do here, get this a little better for you. Area of a circle equals pi times the radius squared. Okay, pi times the radius squared. Now the radius is from the center to the edge. Right, so that's from here to there. That's the radius. Right, and I want to find that. I know the area is 16. I know a equals 16. So 16 equals pi times the radius squared. So now if I divide both sides by pi, and then I take the square root of both sides, I find that, let's see here, the square root of 16 divided by pi equals, and that's my radius, 2.567. So r equals 2.256. I'm going to stop right there. That's my radius, okay? And the square from the center to the edge is 2. Okay, so from here to here on my square, right, all the way across is 4, so half of that is 2. Okay, so now I'm finding the difference between how far out the circle goes and the rectangle goes right here at this point. Okay, it says how far to the nearest hundredth of an inch does each corner of the bun stick out from the bun? Explain. Does the burger stick out from the bun? Okay, so to find that, what I need to do is take my square which I know is 4 by 4, and I want to find the length of that diagonal. So this is A, and this is B, and this is C. So 4 squared plus 4 squared equals C squared. Right, so this is 32 equals C squared. And if I take the square root of both sides, I get 5.65685. Now, what I'm really looking for is half of that. I'm looking for this distance right here, because I found the radius of the circle. I know how far out that goes. So half of that distance, so I'm going to divide by 2 and get 2.828. Right, if I divide this by 2, divide that by 2, I get C divided by 2, and I get C is approximately 2.828. So the difference between that and this right here, let's find the difference. So I'm going to subtract the square root of 16 divided by pi, and that's going to give me 0.57. Okay, so how far to the nearest hundredth of an inch does the corner of the burger stick out from the bun? So the burger is square, and this right here is 2.82, and the bun is circular, and this right here is 2.2568, and so the difference minus 2.256 is approximately 0.57 inches. Let's put that right up here. Let's see. Corner of the burger sticks out from the bun approximately 0.57 inches. Because 1/2 the length of the diagonal is that much greater than the radius of the bun. Okay, that was definitely a challenging problem that requires us to kind of pool all of our collective knowledge, our mathematical skills. Now, how far does each bun stick out from the center of each side of the burger? So what's the difference between the radius of the circle and half the distance across the square? So we know this is 2, and we know the radius is 2.568 more or less. So let's just take that radius of the circle. Let's type that into the calculator like this. Let's do the square root of 16 divided by pi. And then we're going to subtract 2 equals 0.2567. So we're going to round to the nearest hundredth. So we're going to do, looking at that 6, and that tells us to go up with the 5. So 0.26 inches. Let's see. So I'm going to answer that. The bun sticks out 0.26 inches from the center of each side. Okay, now the last part of that problem asks us, are the distances in part A and part B equal? If not, which sticks out more, the burger or the bun? Explain. The distances in part A and part B, well, this is 0.26 and this is 0.57. Okay, so the burger sticks out 0.57 inches from the bun at its widest point, and the bun sticks out 0.26 inches from the center of each side. So the burger sticks out 0.57 inches is equal to the burger sticking out, that's the farthest out, and the bun sticks out 0.26 inches. So I'm going to find the difference between those two, and I find that 0.31 inches is the difference in between those two. So the burger, the square hamburger, sticks out 0.31 inches further from the center. Okay, and that's the end of our classwork and our lecture notes for today. Please make sure you have all that. If you have questions that you need to ask, please ask through the classroom, or send me a text or an email, or just give me a phone call. All right, I hope you guys are all well, and I look forward to seeing you soon.